Hello everyone. In this video, we're going to talk about the third type of word problems based on distance, speed, and time. As you can see on the board, as you can see on the screen, it already says that distance traveled by boat, upstream and downstream. What are these two words? Upstream means when a boat is moving against the flow of the water, means it is moving in the opposite direction of the flow of the river water or the ocean water. Particularly, we are talking about in this case is the river water, and the flow of the river water should not be very fast, very high. It should be a little bit slow moving, flowing water. When the boat is moving in the opposite direction of the water, then we call it as upstream, against the flow of river water. And when the boat is moving along the direction of the river water, then we call it as downstream. Okay, so here we are going to talk about two basic concepts, that is the speed of the boat and the speed of the water, and then deciding on the what is happening between the speed of both of them. Are they adding up or are they subtracting up? We get the speed of the situation in upstream and downstream. Okay, so first thing it says, let the speed of boat, which is going to be a little bit more than the river water, because we are saying that the river water should be not much faster. Okay, so the boat speed of the boat be x kilometer per hour, and let the speed of water, okay, or some places they call it as stream, either way, water or stream or river. Speed of water, speed of stream, speed of river, one and the same thing. Okay, now upstream means that the boat is going in the opposite, is moving in the opposite direction of the speed of the river. Therefore the speed of boat will be little bit cancelled out by the speed of water, because they are in the opposite direction, right? One is in downwards, the other is going the upwards, so they will subtract each other. So speed in the upward upstream situation will be x minus y kilometer per hour, because the boat is moving in the opposite direction of the flow of the water. Whereas downstream, the boat is moving along the along the direction of the water, right? So the speed will increase automatically when you are moving, when you're cycling, okay, and you're moving in the same direction where the wind is flowing, then you don't have to do much. You will be pushed because of the push of the air, right? Blowing wind will push you. But if you're cycling it in the opposite direction, then you have to exert extra amount of energy, because the air is pushing you in the opposite direction, and you're going in the other direction, right? Same way here also, the speed of the boat will add up with the speed of the water, because they are moving in the same direction. Okay, so wherever upstream comes, it's addition of the speed of both the situation, both of them, and that is boat and water. When it is downstream, it's subtraction. Why we are taking the boat speed as the first one? Because nowadays we use motor boats. We are talking about the motor boats which are run with the generator, okay, with a motor which is more faster. Okay, now whenever you come across with the word problems which talk about upstream and downstream, the four sentences that you have to write as the first thing is the speed of the boat, speed of the water, speed of upstream situation, and speed of downstream situation. So let's first write it down, and then we'll read the question. So let the speed of boat is equals to x kilometer per hour, speed of water, you can say, or river, equals to y kilometer per hour. Upstream speed during upstream, sorry, speed in upstream will be x minus y kilometer per hour, and speed in downstream is equals to x plus y kilometer per hour, right? This is the first thing that you have to write. Now we'll read the question. A boat is moving 32 kilometers upstream and 36 kilometers downstream in 7 hours. So this is the first case where I have two parts, upstream situation and downstream situation. So let's say case 1, right? So I'm going to bifurcate into two parts so that it's easier for me to work out. So I'll say this part, this is going to be upstream, okay, and there I'll talk about downstream. So three things which we have to take into consideration: the speed, the time taken, and the distance. Okay. So speed is equals to, yes, x minus y. Okay. You can put kilometer per hour. Distance is equals to, in upstream the question says 32 kilometers. Time we have to find with the formula. Okay. Same way speed in downstream will be x plus y. Sorry, y kilometer per hour, and distance, and the question says so, as 36 kilometers. Can you see it? Okay, now we know that time is equals to distance upon speed, right? So we are going to put that. So let's represent the time taken in upstream as TU, and that is distance upon speed. So 32 upon x minus y. And downstream as TD, distance is 36 divided by x plus y. Total time in this situation is 7 hours. So total time will be is equals to the time taken in upstream and the time taken in downstream. So you will add them up. So that is when we are getting the total time. So it is 7 hours is equals to 32 divided by x minus y plus 36 divided by x plus y. So now if you remember, we have done something like this in reducible form of equations where we're converting the simultaneous equation into the given equation into simultaneous equation, and we did double elimination method. This is the one which I was discussing there. Okay, now let's talk about the next equation. Now the boat is covering 40 kilometers upstream and 48 kilometers downstream in 9 hours. Okay, so case 2. So upstream 40 kilometers, downstream 48 kilometers. Distance is 40 kilometers. Speed x minus y kilometer per hour. Okay. And let's talk about downstream. Distance was 48 kilometers and speed is x plus y kilometer per hour. Okay. So let's talk about the time taken. Okay, so time taken in upstream TU will be 40 upon x minus y, and TD will be 48 upon x plus y. Now, how much time it is taking in totality for this particular situation? We'll read it. It's 9 hours, right? Okay. So the equation becomes total time taken is equals to TU plus TD. Okay. So that is 9 is equals to 40 upon x minus y plus 48 upon x plus y. This is the second equation that we got, right? Now I'm just placing both the equation next to each other to explain what you will do. So the first equation turned up was 732 upon x plus y, x minus y because it was upstream, plus 36 upon x plus y. And 9 is equals to 40 upon x minus y. Okay, so what we are going to do here, let 1 upon x minus y is equals to a and 1 upon x plus y is equals to b. So what are we going to get as an equation? 7 is equals to 32a plus 36b, and 9 is equals to 40a plus 48b. So now you end up with double elimination method. Okay, first you will solve the equation, you'll get a and b. That will give us the second equation, that is x minus y and x plus y, and double elimination method has to be used to solve these two equations. Hope you are clear with the equation. How do we get the equation part? Okay, let's take the next question for a quick understanding. I'm just going to give you the situation. I'm not going to do the whole step here. So first 4 sentences, let the speed of the boat be x kilometer, let the speed of the stream or water be y kilometer, upstream is x minus y kilometer per hour, and downstream is x plus y kilometer per hour, right? Now case 1 here, they are saying 24 kilometers upstream, 28 kilometers downstream, time taken is 6 hours. So total time will be time taken upstream plus time taken downstream, which is equals to 24 upon x minus y plus 28 upon x plus y, and time is 6, right? Speed, distance is 24, speed is x minus y, distance is 28, speed is x plus y. Okay, and in case 2, total time taken, again time taken in upstream and time taken in downstream. So how much time they are taking? 30 kilometers upstream, 21 kilometers downstream, 6.5. 6.5 can be 13 by 2 kilometers. Okay, that is equals to upstream is 30 kilometers per hour, 30 upon x minus y, and this will be 28 upon, plus 21 upon x plus y, right? Clear? So then you will do the double elimination and you will solve it, right? Next question. The boat is traveling 12 kilometers upstream and 40 kilometers downstream in 8 hours. 16 kilometers upstream and 32 kilometers downstream in same time. So again, the four sentences: speed of boat x kilometers, speed of stream y kilometers, upstream speed is x minus y, downstream is x plus y. Okay, so now let's do this. That is the time taken, tu plus td, right? That will be equals to 12 divided by x minus y plus 40 divided by x plus y. Total time taken 8 hours, right? Oh, sorry. Okay, and here total time tu plus td. Upstream the distance covered is 16 kilometers, right? And downstream the distance covered is 32 kilometers. Total time is same. Same means 8 hours, right? So you got these two equations. Again, you will be doing double elimination to find the answer. Okay. I've just given you the hint. The remaining is your part. The next two questions are a little bit different. Why? If you read the question, Ritu can row downstream 20 kilometers in 2 hours and upstream 4 kilometers in 2 hours. So in this situation, the four sentences which we write is same. That is, let the speed of boat is equals to x kilometer per hour. Let the speed of water is equals to y kilometers per hour. Upstream is x minus y kilometer per hour, and downstream is x plus y kilometer, x plus y kilometer per hour. This part is going to be same, okay? But then we don't have two cases in each case, upstream and downstream. Here the two cases are, one case is exclusively talking about the downstream situation and the second case is talking about the upstream situation. So your first equation is going to be the downstream situation, means your first equation you are going to get from there. That is the first sentence. The distance traveled is equals to 20 kilometers in 2 hours. So the speed is equals to distance upon time. Right? So x minus y is equals to 20 kilometers upon 2. Yes. So x minus y is equals to 10. Right? That is my first equation directly. And in the second case, it is going to be upstream, where they are saying 4 kilometers in 2 hours. Again, speed is equals to distance upon time. Upstream means x plus y, which is equals to 4 kilometers upon 2, which is x plus y is equals to 2. So that is my second situation. So directly I am getting my equation. Okay. Am I clear? Okay. Okay, so again, upstream is a single situation where the speed equal distance upon time will give me the first equation. Downstream is the second situation where again speed is equal distance upon time will give me the second equation. This is a direct elimination. You'll get the answer directly. Okay, same way in the next situation. Downstream 8 kilometers 40 minutes. Okay, so x minus y is equals to 8 kilometers 40 minutes will be 2 by 3 because 40 upon 60, which is 2 by 3 hours. Okay. When you change it, you'll get x minus y is equals to 24 by 2, which is x minus y is equals to 12. That's the first equation. Okay. And the second equation will be the downstream, where it is taking 1 hour. So x minus y, the same distance, 8, traveled in 1 hour. So your first, x plus y. X plus y is equals to 8. So this is my upstream. The left hand side is your upstream situation, and the right is your downstream situation. Okay, so here again there is no double elimination. You will do a direct equation. Okay, am I clear? So these two questions are direct, simpler ones, whereas these questions had both the situation upstream and downstream in one condition. Okay, so hope it is clear. Thank you.